In this video, we're going to study another differentiation rule that will allow us to study the derivative of the composition of differentiable functions. So, if we want to find the derivative of a function given by square root of x squared plus 1, for example, the differentiation rules that we have seen so far are really not helpful at all. So we need something else. So what we're going to see is that we can write f as the composition of two functions. One function, g of x, is going to be x squared plus 1, and then the other one is like f of u equals square root of u. So then my function big F is just f of g of x. And then we just need to find a way to compute in the derivative of this. So what the chain rule is telling me is that if I know that g is differentiable at x and that f is differentiable at g of x, then the composition defined by f of g of x is differentiable at x, and the derivative is given by f prime of g of x times g prime of x. So using the chain rule, we work from the outside to the inside. So if I want to do the derivative of the function f of g of x, what we do is we take the derivative of the outer function evaluated at the inner function times the derivative of the inner function. So let's see how we do it in an example. So we want to find the derivative of this. Well, we said that this was a composition of a function f of u equals square root of u and g of x equals x squared plus 1. So the derivative of f of u is 1 over 2 times square root of u. The derivative of g of x is just 2x. Those two are quite easy to compute. So now that we have this, then what would be the derivative of the composition? So well, this would be f prime evaluated at g of x. So that would be 1 over 2 times square root of g of x times g prime of x. So this is 1 over 2 square root of x squared plus 1, that is g of x, times 2x, which is just g prime of x. And here, well, we can cancel the 2's to make things look a bit nicer, and this is x over square root of x squared plus 1. You can, of course, skip steps and go a bit faster. You don't have to write every time every single function involved in this composition, but it helps when we're starting to make sure we don't miss anything.